the landscape architect for the project. Wendy was the project manager for the contractor Mowlem's management. Anthony Field, AYH partnership. Chris Baxter, RW Gregory's, the services engineers. Gerald Stone, AYH Health, project managers. Andrew Mason, Moya partnership, project architect. And Ian Menzies from Charles Weiss partnership, the structural engineers. And myself, Roger Burr, Moya partnership, I was the director in charge. The building is a centre for the diagnosis and treatment of cancer. The client, in fact, was a double-headed client. The South East Thames Regional Health Authority were the principal client, and they worked with the Maidstone Health Authority to procure the Oncology Centre. The main requirements of the project at the time were related to the shortest timescale to bring the centre on stream in 1993. At the same time, using the most advanced equipment for the centre. This was both for treatment and diagnostic purposes, often computer-driven technologies. The design team as a whole had, in fact, been gathered together some years beforehand, towards the end of the completion of the main hospital on the site, the Maidstone District General Hospital. And in fact, there had been a hiatus of several years, whilst the National Health Service reconsidered the criteria for treatment centres or radiotherapy centres in the country as a whole. The result of this review ended up with a certain number of units in the whole country, and the one for the South East region was designated to be at Maidstone. It's an independent unit, although it receives some support from the existing hospital on the site. The basis of the design team was drawn from the original group that completed the Maidstone District Hospital, which was a new hospital completed about 10 years ago on the site, in fact by the same contractor, Mowlem's, same architect, Powell partnership, same engineers, Charles Weiss partnership. But for the Mid-Kent Centre, there had been a change. The client had their own engineering department, which they kept for the Oncology Centre, and they also brought in their own project managers, who were then called Project Management Services, to help manage the whole scheme from the client point of view. Constraints to the design of the building emanated from its need to connect to the existing hospital on the site. It actually fulfilled the ultimate phase of development in that direction of the hospital. There were particular aspects in terms of landscaping, and there was also the difficulty of dealing with a rising ground level, which meant that the new building connected to the existing building by a bridge component. The client, under the auspices of the project manager, had spent some time developing a detailed brief which covered not only the policies of the various departments of the building, but involved every single room, every piece of engineering in that room, and every element of equipment. The process of developing the brief came about through the interaction of a project team, which is a team assembled on the client side, involving users, the financial people, the administrators, and on the design team side, which involved the works professionals. They met on a regular basis, developing the design and ensuring that every aspect of the detailed brief met with the user's very particular requirements. The basic design approach was very simple. The centre was divided into three component parts. The first and largest was the treatment block. The second was the nursing section, that was the inpatient part, the care part. And the third was an independent service building which provided all the necessary support for this development. The treatment of the three components related to their relationship to the existing hospital to some degree. The nursing section was developed as an extension of the existing hospital, and it connected by a bridge to the new treatment centre. The basic form of the treatment centre was devised around a courtyard space. The purpose here was to fulfil two objectives. Firstly, to provide a very simple circulation pattern around the treatment block, so there was a clear and obvious movement for outpatients, people receiving treatment, or people waiting to receive treatment. And secondly, as a space, presented a visitor with an optimistic and positive view, flooding the interior with daylight and celebrating some of the more positive aspects of life: water, plants, and a pleasant outlook.
The client placed great emphasis to the whole of the design team
on the need for a user-friendly building. Cancer patients are probably the most traumatised that the NHS treats, and as a result of that, the need to make the building, particularly where it actually interfaces with the public front, a very soft, welcoming, friendly, optimistic atmosphere was considered of high priority by the client, and monies were allocated specially to fulfil this need. Thank you, Gerald, for providing the client's point of view on the design approach. The development of the design process started with the appointment of the project managers at the very outset of the scheme. Following that, the design team members set to work, and they in turn brought in further consultants. That was the landscape architect and the interior designer. There were also significant technical inputs that started at the very beginning of the detailed briefing process. That was on the client side, the scientific officer, whose principal task was to feed into the design team all the necessary aspects of design for radiation protection, the use and handling of difficult materials, and of very particular relationships of functions and their physical requirements. At the same time, the fire officer was another important formulator of the detailed design aspects, and the local fire brigade were part of this detailed consultation that occurred at that period. Yes, Gerald, were there other consultants? Not so much that there were other consultants, but it's possibly worth pointing out that the client specified that the building should be designed to take any equipment, rather than just that was specified for it, in terms of the specialist equipment, that is. The fact that the bunkers, the linear accelerator bunkers, were designed to take any linear accelerator currently on the market is significant because of the need to provide services to feed all and any sort of equipment that was put in there. Thanks, Gerald. It was the desire of the client to keep open his ability to select up-to-the-minute technology and also to be able to respond to rapid changes that were occurring in the diagnosis and treatment in this area. And we'll come on to see how that was organised by the project manager and the design team as a whole. In terms of town planning aspects, the nature of the development was not critical. The hospital sat in its own grounds. There were no significant urban design relationships beyond that, which were set up within the campus itself. I think now I would like to expand this discussion into more detailed aspects and look at some of the more specific contributions of the consultants. I'd now like to introduce Ian Menzies to give a more detailed explanation of the structural engineer's contribution.
Thank you very much, Roger. There were two fundamental problems to be solved in the structural engineering context. The first was one that was well known from the involvement we had had with the previous main hospital project, and that was because of the underlying nature of the site. Because of the way in which the underlying chalk is folded, the area of barring on which the hospital is located is notorious for the unpredictable appearance of what are called swallow holes, where the surface of the ground suddenly vanishes from underneath one's feet. We overcame this potential problem on the main hospital by constructing the foundations as a thick, 1 metre approximately thick raft, which was capable, should such an event occur, of spanning a swallow hole of up to approximately 6 metres in diameter. And it was decided, after looking at one or two alternatives, that this was still the most appropriate foundation system to adopt for the Oncology Centre.
And not only did it help solve the structural engineer's problem, but this approach gave great benefits and opportunities by introducing an interstitial layer between the foundation and the actual used slab, where we could run drainage and facilitate that part of the works.
That's all right, thank you, Roger. The second problem from the structural engineering point of view was that of the shielding from radiation escape within both the high and the medium energy linear accelerator units. This involved very considerable discussion with the health department's physicist in order to ascertain the fundamental physics requirements of this. The most cost-effective solution was to utilise dense reinforced concrete to form the shielding, and this necessitated walls of up to 1 metre in thickness and a roof slab over the high energy accelerator of excess of 2.5 metres in thickness. So it was a very considerable logistical exercise to construct that.
Could I just say that it wasn't the health department's physicist, it was the region's physicist?
Yes, I used the wrong term. I should have said the regional health authority.
The walls are up to 2.5 metres, as well as the roof.
The other, probably a significant element, of course, are the services in terms of the project. They constitute getting on for half the actual value of the works. And in this particular context, the nature of the equipment, of course, was complex, requiring special conditions. And I'd like Chris to elaborate a bit further on the services components. Like Ian, we had a number of problems to solve, quite significantly to do, in particular with the radiation protection part. If you can imagine that these bunkers are completely surrounded in concrete, we therefore have a fundamental problem as to how to bring services into those rooms, both electrical services, mechanical services, air conditioning, ventilation, and every other aspect that are required. We needed very careful coordination with the building and the structure as it was actually created, and necessitated a lot of work to do with builders' work early on in the contract to ensure that these routes were left open to enable services to be brought in at a later date. The other fundamental problem we also had to get over, which Gerald already touched on, to do with the client's requirement for a domestic or hotel-type environment into the building, was to always try and ensure that services remained unobtrusive, was always in sympathy with the architecture of the building. All of these services were derived from a service centre, which is effectively built at the end of the project. We did in fact take a number of primary services all the way across the roofs of the building on an upper level street. These services were terminated in the service centre, and one other interesting feature is that, like a lot of hospitals, an underground subway was created between the service centre and the treatment block. I think one might say here that the approach to the design of the services, or the design of the centre, was really to only be dependent on artificially supported environments where there was an actual clinical or technical need. Generally speaking, the rest of the centre and of the nursing sections were as naturally ventilated as they could be. That's true to a larger extent, yes. Certainly the treatment block with its specialist rooms for the simulator machines and the linear accelerator machines all required reasonably close control ventilation systems. Could you just perhaps mention the energy-saving aspects of the design?
Certainly,
any particular
yes.
measures that were...
Really, two measures were taken in particular for energy-saving purposes. Most of the air handling units which provided mechanical ventilation to the treatment block were provided with heat recovery coils from the extract systems, and considerable use of low-energy lighting fittings were used throughout the development as well. So in that respect, there was a considerable amount of energy-saving equipment within the building. Typically, hospitals are not easy to do this with.
We did, of course, have a highly insulated envelope.
Yes.
And the whole system was actually sort of plugged into the building management system for the whole of the hospital complex. Another, of course, very important contribution here was the quantity surveyor, who helped establish and manage the control of costs, and perhaps Anthony Field would like to elaborate further.
Our main problems was coming in after the other consultants and dealing with their various problems that they had, and doing cost analysis, seeing which is the best way of getting around or over these problems, fitting in with the client's requirements, and attaining a budget that the client is happy with.
Could you elaborate perhaps on the establishment of a cost plan in order to shape and help regulate the design process and subsequently into
the cost plan is established on how many people are due to come into this hospital, how many beds you've got, and then on top of that you get what they call an on cost, which is the cost of actually making this system work, how the hospital is going to get in there and work. On this scheme is very high because a lot of the accommodation provided was not standard, very exclusive to this project. Once we've got this budget set up, we then develop this in consultation with all other consultants. We get feedback from all consultants, and we adjust the monies as necessary and try cost control against each element, setting up budgets, targets of which each element has to be designed to. And this is a very good process of which to report back to a client, showing where elements where perhaps we need more money, we don't need so much money. It's very much a two-way exercise.
Thanks, Anthony. Part of the other design inputs were on the landscape design and the interiors, and Jeremy Lever will tell us a little bit more about the landscape approach.
Basically, when I joined the team, the first thing I had to do was to do an appraisal of the surrounding areas, because the building was not to stand in isolation, but the only elements, strong elements, that one could relate to were two small woodlands on the northern boundary. They were coppiced, sweet chestnuts. Namely, they would be cut down every 7 years, a 7-year cycle, so it was not a permanent feature. But what was very clear was that the degree of exposure of the future buildings, and the existing ones for that matter, from the strong north and northeast winds, that there was no shelter belt planting there to reduce the velocity of these winds. So that was one of the first thing that one realised: one would have to establish a strong sense of the terminal to the landscape, because the service station is the most northern element. In landscape terms, I had to respond to this situation by forming a link between the existing landscape and this group of buildings. Another aspect of it was to give clarity to the building form, both for pedestrians and drivers. The other thing, of course, one has to have a sensitive response to the needs of the patient, staff and visitors when designing the 3 courtyards. So in general terms, there is the bigger area, the surrounding area, a way in which one is going to bind the buildings into the local landscape. There was the protective aspects of it from the weather conditions, and there was the thing of giving clarity and understanding for people approaching the buildings.
Thanks, Jeremy. The interior design was perhaps the final element that came together in this detailed interaction. John Haddock, in fact, was the designer here, and he worked in conjunction with the architects and the design team, developing an interior scheme reflecting the client's desire to have an ambience that was both positive and sensitive to the state of patients entering into the centre. The main reception and circulation areas, I think I mentioned before, had deliberately a greater slice of the budget to enhance their finishes. There was a combination of the use of natural finishes, timber veneers, timber, to soften the otherwise rather more clinical nature of the unit. A high dependence on the natural lighting meant that there was a use of bold colour, but one not to stimulate but rather to calm blues and more neutral greys. The technical aspects of the interior design also involved specialist testing of materials to ensure that they weren't absorbent to electrons and could have any radioactive carryover. Also, other materials had to make sure they weren't likely to fade under radioactive exposure. And, of course, the ever-present requirement to be clinically sound, i.e. not leading to the growth of infections or bacteria. So there were off-the-scene testing going on all the time of the initial selections of materials and finishes. In the end, these were all brought together as was the whole of the design, to various presentations to the client groups to get final approval to the whole project. Perhaps at this time one might move on and look to see how the project was procured, because it had particular problems. We've mentioned how the actual centre was in 3 parts: the service centre, the treatment block with its front door, flying canopy, and then the inpatient part, which was actually more of an extension to the existing building. There were in fact 2 further problems. One was the need to increase the size or the capacity of the present kitchen in the hospital, which was going to serve patients. And the other was the need to increase the capacity of the mortuary. These were both difficult problems because they were part of the existing hospital and would mean that works would have to occur within that existing situation, and they had to come on stream in readiness for the treatment block, in readiness for the new centre, so they'd have to be in advance. There were also the problems to deal with the interfaces of the nursing section, where it actually is physically connected to the existing hospital, and there would be problems there of maintaining the nursing sections without disrupting patients, staff and the general running of the existing hospital. So there were all these difficulties. There was also the need to keep open for the client the opportunity to respond and react to changing treatments and advances in technology. So a decision was made at a very early stage on a particular method of procurement, and I'd like here for Gerald, the project manager, to introduce the basis behind that selection, and perhaps we could expand that to include other members of the team. Gerald, perhaps you could talk about the nature of the contract, type of contract.
The type of contract chosen to procure the Oncology Centre was a JCT 87 management contract. This was somewhat revolutionary for the client to consider. It was the first of the sort they'd ever done. The main purpose of using such a contract was a keenness on the part of the client to see work started on site at an early date, so that credibility could be given to the project as a whole, as it had been in the planning stages prior to this team's establishment. JCT contract is a variation of the standard form of contract that splits the building of the contract into individual contracts for its component parts.
So, I think one of the first sort of benefits the type of contract would give the team and the client was the ability to bring the contractor on at a very early stage, and before in fact we completed all our detailed design work. And it also meant that by having the contractor on board so early, and part of that development process, that should there be the need for any change on a technological or even a planning change within the building, we would be more readily and more easily able to achieve that without incurring what might otherwise have been severe financial penalties or time penalties in a more conventional type of contract. It was quite unique for this client to use a flexible approach in that way. And we'll come on to some of the issues that came from that. But perhaps, Andrew, you might like to expand on how we actually chose the contractor, having decided on the method.
I think one ought to explain to those who are not au fait with contracts that a management contract is where the client employs the contractor to manage the project on his behalf, and the contractor does not actually construct the works. And therefore, it enables the contractor to become a member of the team, and therefore procure building speedily and without delays to the project.
I think it should be said that the adoption of a management contract also enabled the client to respond through the design to any changes in costs that were received as packages were returned. Also, I think it should be said that as this was a revolutionary procurement method for a health authority, and the health authority was a little bit concerned about the risk he was taking, amendments were made to this standard contract to enable him, if the costs were becoming a problem, to be able to stop the job and rethink the situation, so thus reducing the client's risk.
Thanks, Anthony. But shall we just look at how the contract was selected to run with that form of contract, because they became a very important part of the process. Andrew, I know you were involved in that selection procedure. Perhaps you could just briefly outline what happened.
Clearly, a number of contractors were aware of the project going forward and had approached our client to be considered, and a shortlist was drawn up of a number of major contractors with management experience that we felt were able to carry out this fast-track programme. And each contractor was given an opportunity to make a presentation to the design team and the client to ensure that we were happy with the quality of the contractor to be put forward for a fee bid. Fee bids were invited, and we were happy with to run with Mowlems, who had a wealth of experience having worked on the original site.
I think this might be an appropriate moment, Andrew, to ask Wendy to add her views on this appointment, and in fact, how quickly did Mowlems get involved, and their first sort of contacts with the design team.
John Mowlem Construction became involved with the project in May 1990. We were initially employed for pre-commencement services, and after 4 weeks, unfortunately, the client had funding problems in other areas, and the job was stopped. So in conjunction with AYH, we formulated a number of options to go forward in terms of funding and timing to allow the job to continue. And the client accepted one of these options, and then we restarted work in pre-commencement in October 1990, which was some 6 months before the construction actually began. This allowed us to be involved with all of the design team, with the design process, giving our advice on buildability of the project, and also to put together the works packages. We commenced initially with the refurbishment of the mortuary and the refurbishment of the kitchen in February 1991, and work commenced on the construction of the Oncology Centre on March the 4th, 1991.
I'd like just to elaborate a little bit more on the notion of the concept of packages in relation to the management contract and how they were generally used in its organisation. Perhaps, Wendy, you could elaborate further on that.
As a management contractor, we're employed to manage the contract. Therefore, we put a team of supervisors and professionals on site to manage the construction process. But we don't actually do the construction work ourselves. For this, we employ works package contractors. And in the case of Mid-Kent Oncology, those works package contractors were employed on an elemental basis, i.e. we had superstructure packages, we had mechanical packages, electrical packages. All in all, we had 37 different works package contractors, and those were chosen in consultation with the design team. We put together the list of the elements that we wanted to go to, and they were procured at the early stages of the project, and this ensured that one could start procuring the earlier packages as the design for the later packages was being completed.
Great. Perhaps, Anthony, you might like to comment here on how the client's risk or exposure to a contract where he didn't know quite where all the packages were at one time, what sort of money he'd be in for, how that was controlled.
Certainly. We procured the mechanical and electrical packages fairly early, as these had nearly 50% of the total value. So the majority of the financial outcome was known at an early stage, and a clause was written into the contract that the client had the right that when 60% of the packages had been let, that he could stop the job if it deemed necessary, due to financial reasons. This reduced the client's risk substantially.
It was just a very useful safeguard from a client's point of view. Generally speaking, certainly the work started off in a very orderly and proceeded diligently, but as time went by, things happened. One of the major subcontractors fell into trouble and went bankrupt during the works. What actually happened then, and how important was it?
It was fairly important, and it had a fundamental effect on the completion of the project. In employing works package contractors, at the shortlist stage, we do financial checks on all of the shortlist candidates, and in particular with mechanical and electrical works, because they represented a large proportion of the project, our accountants actually checked the books, and the current trading books for both the mechanical and the electrical subcontractor. Unfortunately, in a recessionary times, they can have perfectly good trading facilities at the start of a project. The electrical contractor actually went into receivership in June 1992, possibly the worst possible time in the construction of the project. The most critical time in the construction of a hospital is the time between putting up the stud work and completion of the installation of services into the walls. That's mechanical, electrical and plumbing services, plus all of the noggins to take fittings that go on the wall afterwards. Unfortunately, the electrical contractor went into receivership almost halfway through the first fix activities, which meant that effectively the entire job could possibly have come to a complete standstill. We put matters in hand very quickly to try and overcome this. We directly employed a not small number of the electricians on site to enable some works to continue and to allow some continuity for following works contractors. And at the same time, we entered into negotiations with the mechanical contractor to get a price to complete the project. And he commenced works at the beginning of August to complete the project. There was a delay of 11 weeks. However, I think it's reasonable to say that within that time we also accommodated a large number of additional elements.
On the question of the programme, although the completion of the project was later than Mowlem's original contract completion date, it was still within the time that the client had originally envisaged for the project to be completed, and was in accordance with his own commissioning programme.
Another important operation that occurred during the contract, which was foreseen, but nonetheless equally difficult and complex, related to the construction of the linear accelerator rooms, the rooms with the high-tech equipment. We referred to them earlier, and perhaps Ian would like to talk a little bit more about the actual construction of these.
Construction of these particular rooms involved the placing of very thick concrete elements, both in walls and in roofs. The formation of construction joints within these walls would have provided a possible path for radiation to escape beyond the shielding. Similarly, the formation of the normal shrinkage cracking that usually occurs in very thick concrete sections would again have provided possible escape routes for radiation. Both of these eventualities were avoided, and the courses of action which were adopted were: 1, to replace 70% of the cement content of the concrete mix with ground granulated blast furnace slag in order to reduce the heat production that inevitably occurs as concrete sets. It's an exothermic process. And the second very innovative move, which was taken in conjunction with Mowlem's management contractor and with the package concrete contractor, was to specify that the concrete had to be placed at a temperature not in excess of 10 degrees centigrade. In order to achieve that, the concrete, while it was being placed, had to be cooled by injecting liquid nitrogen into it. This was highly effective. The finished product has been very successful, and so far as one can tell from the visual inspection and from the radiation protection testing that was carried out, it has been totally successful in eliminating both construction joints and shrinkage cracking. Yes, it wasn't the first time it had been done, but it was certainly a very new process. It involved placing in one continuous pour something like 375 cubic metres of concrete, which is quite a logistical size of its own.
The works were undertaken by PC Harrington, and they were fortunate in that ARC and BOC, the concrete manufacturers and the British Oxygen Company, were very keen to promote this form of construction, and therefore were very helpful in the design of the mix and in the process of actually doing the works. And this brought up 13 hours pouring time. So it was quite a logistical problem, and I think they coped very well with it. And I think the resulting is concrete of extremely high quality, and in fact probably the best finish of concrete that one's seen for quite a while.
Gerald, there were, during the course of the development of the design, and indeed to some extent on site, there were changes that occurred at the client end. I mean, perhaps could you elaborate on those a little bit?
Yes, of course, Roger, thank you. Mention was made earlier of the requirement of the funding of the job that the job had to be put on hold for about 6 months. And whilst, obviously, various options for considering how the payment would be carried forward, time was also used fruitfully to re-examine the content of the building. The treatment for cancer sufferers is very much front leading-edge technology at the moment, and there are many new processes for easing the suffering of the patients that are being developed. Opportunity was taken to incorporate some of these facilities into the new building, as the design had effectively been stopped, the design process had effectively been stopped. And whilst it was felt that it would be disruptive to change the layouts and the functional contents at this late stage, it was considered advisable, if the centre was to perform its role as one of the finest centres in Europe, that these sort of facilities were included. Certain innovative designs were drawn up, especially for part of the treatment which is called brachytherapy, which doesn't involve deep layer radiation, but rather more the surgical implanting of elements that are then radiated whilst the patient is being kept in a supine position. What the effect on the patient is that instead of having to lie absolutely immobile for 4 or 5 days, the treatment can be concluded in something like 20 minutes with quite minimal after effects, both medically and psychologically. The help of the region's physicist was enlisted by the designers to provide daylight in some of these rooms, and this, as far as we're aware, is unique in any centre of this sort. And this was done by the expedient of providing radiation shielding walls outside the very large windows, which enabled the patient to feel much more human in as much as he can see what daylight is doing. He can see out into the outside world. Perhaps, Jeremy, you can elaborate further on this too.
Yes, this I think was one of the best decisions from my point of view. Providing a window obviously was brilliant for the patients, but it also gave me a chance to think about what one may place inside the shield wall. A shield is really, one feels, is keeping something out. This is keeping the radiation in. And so the curved shape in the form of a coil winding up was providing shelter for the rooms and people working outside, as well as forming not too oppressive an enclosure, because the difficulty was that since it radiates out from the position of the patient in the same way, you might say that patient at low level would not be able to see out. But so if one could bring a bit of the garden inside, it would make the patient realise that the patient is not so trapped within. And to this end, I was able to introduce a tree, a gladitia, which gives the feeling of the sun is on it. These shields were providing a lot of shade as well. And it's quite nice if one can give the feeling of the sun is out. And on this tree, in actual fact, it's a yellowish leaf and gives that nice glow within the rooms. Also, as a chance to bring in other materials, which maybe sound a bit pretentious, but if one produces series of boulders and rocks and things like that, and plants, there's a feeling of season and longevity and so on. So trying to associate those sort of feelings with this very small space, one was attempting to improve the lot of the patient.
I think the second and possibly even more fundamental change that was made to the project as the project evolved was the proliferation of the computer equipment within the building itself. When we completed the initial brief for the job, the room specification sheets contained nothing more than a requirement for a computer outlet, and then not in every location. As the project evolved and the sophistication of the treatment and management facilities of the centre became more and more known, it was quite obvious that this initial provision was by no stretch of the imagination sufficient for the uses to which the building was to be put. Subsequently, a complete reassessment of what computer systems would be likely to be required was made, which caused immense headaches for the design team to try to incorporate. Computers were being used for such things as the verification, recording and management of the computer systems that controlled the treatment machinery. They were being used to transfer images digitally between various parts of the centre and various satellite centres scattered around the southeast of England. There was a need for a connection to the hospital's management system, which, unfortunately, as far as the centre was concerned, was not actually in existence when we started to design the computer systems themselves. There were also a number of other interfacing computer systems, and all of this required a huge input from the services engineers particularly. Through you, perhaps Chris could sort of elaborate on how we overcame some of those problems.
Certainly. In principle, a lot of the additional computer equipment to be installed in the building was in the control rooms and control areas which adjoin the specific treatment rooms. All of these areas were totally redesigned, not only by ourselves but the architects, to ensure that the provision was there for now and the future to uphold a considerable amount of upgrading of computer system, software and hardware. This meant mainly including a vast amount of additional internal carcassing and trunking systems and power systems to uprate what had already been included for, which, as Gerald has already said, was totally inadequate. In addition to this, because there were so many links to various other areas within the Oncology Centre and the hospital, we also had to get involved in providing an additional carcassing system at the roof level to transport local area network systems throughout the rest of the building. This was done at a time, and correct me if I'm wrong, Wendy, where a lot of ceilings were already up in various areas, and this involved, obviously, an additional amount of time for the contractors to sort out how to program around where they were trying to finish, and yet maintain a substantial sort of variation in carcassing of services. Additionally, we established, I think, 3 computer hub network rooms, which needed enhanced air conditioning, and certainly enhanced power sources as well. And these were taken on board in an individual way, whereas a lot of the building was air conditioned by central plant. This now really necessitated split system air conditioning units being installed in the separate rooms because we were far too far down the line with other major equipment to change it.
Thanks, Chris. One of the features, I think, generally of the project was the, once one had understood and dealt with the patients and their requirements, one of the other key factors was the equipment, much of which was extremely expensive and highly sophisticated. We've mentioned the construction of the enclosures or the rooms that house the linear accelerators, but the actual procurement of those machines was one of the guiding factors in the development of the whole project, since they constituted a great financial commitment and a technological commitment. I think, Wendy, would you like to expand on the requirement to bring these spaces on early so that the client would have the opportunity of commissioning them at the earliest opportunity in the project, and how that impacted in your organisation of the works?
Obviously, in keeping with the fast track, there was a requirement to bring on the linear accelerator machineries and some other machines at an early date, overlapping the construction process. Because although they take a relatively short time to actually install, so some 6 to 8 weeks, they take an inordinately long time to commission and get into correct working order. So to facilitate this, the linear accelerator, bunker areas and other key areas were targeted for early completion, and those were completed by a certain set of dates, and then they were effectively cordoned off to allow the installers to have direct access into those rooms.
During the whole of the construction period, the design team as a whole were, of course, active, responding to these changing circumstances, despite the fact that the sketch scheme had been agreed and determined prior to the construction getting underway and the management contractor coming on board. As architects, we coordinated and monitored all these effects and changes, ensuring that the design principles that were established with the client and the user groups at the outset were being maintained and, where possible, enhanced. I think we mentioned earlier how, as the cost plan evolved, and we could begin to identify that the nature of the market was allowing a greater opportunity to give better value for money for our client. We then started to produce proposals in consultation with them, seeking where possible to enhance some of the earlier specifications. Areas where this occurred was particularly related to the interiors. The reception area, where we used a rather unusual form of seating, a serpentine seating, which is a combination of beech, natural wood, and upholstered furniture, gave a very distinctive entrance to the unit. As such, it was an enhanced feature, something we were able to do by responding rapidly to the opportunity offered by the cost plan. In the same ways, we began to develop a works of art program for the building in conjunction with the client, looking to acknowledge sites within the building, both in courtyards and in the spaces generally, where specific works could be commissioned, and that is actually now continuing as a process. 2 are already in place and others are planned. We'd now really like to sort of summarise the extent of our discussions. I think probably the key things from our point of view, the people around the table, has been the nature of the teamwork involved on this project. The combination of the contractor working very closely as a member of the design team, responding directly and rapidly to a client who has very complicated and very specific needs, which in themselves do change quite quickly. It's interesting to note, even after the completion of the project, that change is still part of the unit.